Hello everybody and welcome to lesson 14, Unbalanced Transportation Problem Solution. Previously, in lesson 13, we have discussed about balanced transportation problem solution using the three methods. And now, we proceed with unbalanced transportation problem with three methods. So the objective is finding the initial feasible solution for unbalanced transportation problem. The methods used to find the initial feasible solutions are the northwest corner method, the minimum sale cost method, and Vogel's approximation method. Actually, the steps are the same with what we have discussed in the previous lesson. Steps of northwest corner method is the first one is find the northwest corner sale, that is x11 of the transportation tableau, and the second is allocate as much as possible to the selected cell and then adjust the associated amount of supply and demand, and the last one is cross out the row or column with zero supply or demand. Let's proceed to the previous example, but now we make it unbalanced transportation problem. So let me add this supply 12 plus 17, 29, 29 plus 16, 45, but the demand is 40. So supply is greater than demand, so it is unbalanced transportation problem. It is unbalanced because the supply is 40 greater than the demand, which is 40. So here we have to add dummy demand. We have to add dummy demand to make it balance. The dummy demand should be 45 minus 45. So it is the difference between the sum of supply and the sum of demand. So it becomes 5. So we have to insert here as D5 with the transportation per unit cost become 0. Here we have to make the transportation per unit cost to be 0 because in reality there is no items to be transported from the dummy variable, that is D5. So these are the transportation costs, that is 0, and here the demand is 5. Now it becomes balanced transportation problem. So from now onwards we can proceed with the same procedure or the same steps that we have used in balanced transportation problem. Step 1, identify the northwest corner cell. So the northwest corner cell from here, from this, is 50. So we have to allocate the supply, and we have to allocate as much as possible to the selected cells. So the corresponding demand and supply are 10 and 12. So we have to allocate 10 will be allocated, and the next is we have to adjust the supply and demand. So this 10 will be eliminated and this 12 will be 2 because we subtract 10 from 12, so the remaining is here 2. So like this, and now we have to cancel out the column or the row having 0 supply or 0 demand. So as you see here 10 is already cancelled, so the demand is 0, so we have to cancel this D1 column. Then the next step is to start or to repeat from step 1. Step 1 is to find out the northwest corner cell. So the northwest corner cell is here 75. So we have to allocate as much as possible to the selected cell. So we have to allocate, we have here 2 and we have here 10, so we have to allocate the smaller one, that is 2, and we have to allocate from here, we have to subtract 2, so we have to allocate 2, then we have just supply and demand, we have to adjust supply and demand, so 2 will be eliminated, and from 10 we subtract 2, and the remaining is 8. Then the last step is to eliminate the column or row having 0 demand or supply. So we have to eliminate row 1 because there is no supply. And the next step is to repeat step 1, to start from step 1 again. So the first step is to find out the northwest corner cell. So as you see, the northwest corner cell is 80. So we have to allocate for these cells as much as possible. So the corresponding numbers to be allocated is 8 and 17. So we have to allocate 8, and we have to adjust the supply and demand. So 8 will be here cancelled, and 17 minus 8 equals 9. So we have to cancel 17, and the remaining is 9. And then the last step, the fourth step, is cancel the row or column having 0 supply or demand. So here, as you see, there is 0 demand, so we have to cancel D2 column. And step is to repeat from step 1. So step 1 is finding the northwest corner cell. So from this northwest corner is 40, so we have to allocate on 40. So the corresponding numbers are 9 and 10, so we have to allocate 9. We have to allocate 9, then 9 will be cancelled, and 10 minus 9, 1, so 1 remains here in the demand. And then we have to cancel out the 0 supply or demand, so the row have to be cancelled because there is no supply here, all are allocated. Then the next step is to repeat the steps again. So let's find out the northwest corner. The northwest corner for this table is this one, and then we have to allocate as much as possible to the selected cells. So we have to allocate 1 here, and we have to subtract 1 from 16. So here 15 remains, and this column have to be deleted because all the demands are allocated. And then again we have to repeat this. So let's start from finding the northwest corner cell. So the northwest corner cell is 55. So in 55 we have to allocate as much as possible, and we have to allocate 10 because 10 is less than 15, and 10 will be cancelled from the demand side, and 10 minus 15 minus 10, 5 remains in the supply side. So we have to cancel out the column D4 because already the demand is assigned. So the remaining step, the remaining process is to repeat the steps once again. So finding out the northwest corner. So there is only one corner, that is this corner, so this cell. So we have to assign, or we have to allocate as much as possible. Then there are 5 and 5, so we have to allocate 5, and we have to cancel from the supply and the row. Then we have to cancel the row S3 row and D5 column because the supply and the demand become here 0. Then let's interpret this table. All the supply and demand are allocated. So the total shipping cost can be calculated by 50 times 10 plus 75 times 2 plus 80 times 8 plus 40 times 9 plus 50 times 1 plus 55 times 10 plus 0 times 5, and it becomes 2250. By the way, this result is the same with the result that would be obtained from the balanced transportation problem. And let's interpret the table. So from S1, 10 item goes to D1 and 2 item goes to D2. From S2, 8 item goes to D2 and 9 item goes to D3. From S3, 1 item goes to D3, 10 item goes to D4, and 5 item goes to D5. That is a dummy variable. Actually, this will not happen because there is no transportation from the dummy variable. The dummy variable is just entered for the purpose of calculation. Let's proceed to the minimum sale cost method. The unit transportation cost play no role in the northwest corner, by the way, because we didn't consider the minimum cost in the northwest corner. We just put out, or we just take the north or the left hand, the upper left hand corner or the northwest corner cell, just without taking into consideration of the costs. So we simply select the upper left hand corner variable and assign the value to it. But with the minimum sale cost method, the initial allocation is made to the cell with the lowest cost. So first we have to select the lowest cost to allocate to that cell. Thus the solution becomes near to the optimal solution than the northwest corner. It becomes better, and the solution becomes better than northwest corner because it considers the cost. By the way, the step is the same with that of northwest corner method, except in the first step we have to select the least cost cell. After that, the second step is allocate as much as possible to the visible cell, and third step, adjust demand and supply. Fourth step, cancel the row or column with zero supply or demand. Let's proceed to the example. So this is an unbalanced transportation problem. So we have to add dummy variable before solving this unbalanced transportation problem to convert from unbalanced to balanced. So the dummy variable, the dummy demand should be 5, that is total supply minus total demand. So we have entered here the dummy demand and make it 5. So from now onwards, the problem become balanced transportation problem. So first, let's select the cost, the least cost. Let's select the least cost. So from all the table, the least cost is 0. By the way, here there are 3 zeros, 1, 2, 3. So arbitrarily, let's select the first 0, that is this cell. So we select here, and then we have to allocate. We have to allocate to this cell. There is 5 and there is 12. We have to allocate 5, and we have to adjust the supply and demand. So 5 here will be cancelled, and from 12 we subtract 5, and here it remains 7. Then after, we have to cancel out the row or column having 0 supply or demand. So we have to cancel D5 column because there is no demand. After cancelling, we have to repeat the step again. So we have to select the minimum cost. That is, from here the minimum cost is, as you see, 45. So sorry, 30 is the minimum cost. So we have to select 30. Then after we have to allocate to this cell, and here we have 7 and here we have 10, so we have to allocate 7 to this cell. Then we have to adjust the supply and demand, so here we have to cancel out 7, and here we have to subtract 10, we have to subtract 7 from 10, and the remaining is 3. Then after we have to check whether the columns or the rows have 0 supply and demand. So as you see, this row has 0 supply, so we have to cancel. And the next step is to repeat the step again. So we have to select the least cost method. Among the remaining cells, the least cost is, you see, 40. By the way, there are two 40s, so let's select this one. By the way, if we encounter 2 cells having equal value, so we can just select arbitrarily, we can just select one randomly. So we select this one, then after we have to allocate to this cell, and there is 16 here and there is 10, so we have to allocate 10, and then after we have to adjust the supply and demand. From here we cancel 10, and from here we subtract 10, and the next task is to cancel out the D1 column because there is no demand. And the next step is to repeat the step 1 again. So from the remaining cells we have to select the minimum cell, that is 40 is the minimum, and we have to allocate for this. There's a corresponding number 3 and 17, so we have to allocate 3, and 3 will be cancelled from the column, and 3 will be subtracted from 17, so 14 remains. Then we have to cancel the D3 column because there is no demand, 0 demand. And the next task is to select the minimum value, that means repeating the step again. So select the least cost, that is from the remaining this unshaded cells. So 55 is the minimum, so we have to allocate for 55. We have to allocate 6. We have to allocate 6 for 55 cell, and we have to cancel out 6. We have to adjust supply and demand. We have to cancel out 6, and we have to subtract from 10, and 4 remains here, and we have to cancel S3 row because the supply is already finished. So we have to cancel out, and we remain with 2 cells. So among 80 and 60, 60 is the least. So we have to select 60, and we have to allocate. There is 4 and 14 corresponding values, so we have to allocate 4. Then after we have to cancel out 4 in the D4 column, and we have to subtract 4 from 14, and the remaining is 10. And we have to cancel out the row or column having 0 values, so we have to cancel out the D4 column, and the next cell is already 1 cell, that is. So when we select from 1 cell, so the least cost is itself, so we have to select 80, and we have to allocate 10, and we have to cancel. When we adjust, we have to cancel S2 supply and D2 demand. So we have to cancel S2 row and D2 column because they have 0 demand and 0 supply. Now we already allocated all the supplies to the demand. Then we can interpret as from S1 7 item goes to D3 and 5 item goes to D5. Actually, this cannot happen because it is a dummy variable and there is no transportation in the dummy. So this 5 item is just not transported from the origin. It remains in the origin. And because the supply is greater than the demand. So here there is leftover of 5 in the S1. And from S2, 10 item goes to D2, 3 item goes to D3, 4 item goes to D4. And from S3, 10 item goes to D1, 6 item goes to D4. This is the interpretation of the table, and the total cost can be calculated by 30 times 7, 0 plus 0 times 5 plus 80 times 10 plus 40 times 3 plus 60 times 4 plus 40 times 10 plus 55 times 6, and it becomes 2100. So this value is actually greater than the previous value, that is 1065. In this case, by the way, in this case, the problem is unbalanced, whereas in the balanced transportation problem, we obtained 2065. But in this case, we obtain a little higher value. Still, it is better than the northwest corner method, that is 2250. Let's proceed to the Vogel's approximation method. VAM is an improved version of the least cost method that generally, but not always, produces better starting solution than what? Northwest? No. Even the least sale cost method. So this one is nearer to the optimal solution. VAM is a technique which is based on the concept of penalty cost or regret. By the way, an operation manager mistakenly selects the higher cost, so there is a regret. Or there is a penalty, or there is a missed opportunity cost to select the minimum cost. So VAM is a technique which is based on the concept of penalty cost or regret. If a decision maker incorrectly chooses from several alternative courses of action, a penalty may be suffered. If there is a mistake happen, or if a manager selects the higher cost, so there is a penalty. And the decision maker may regret and the decision that was made. In a transportation problem, the course of actions are the alternative routes, and a wrong decision is allocating to the cell that does not contain the lost cost. So we may face a penalty cost or a regret. Let's come to the steps. The first one is to determine the penalty measures by subtracting the smallest unit cost in the row or column from the next smallest unit cost in the same row or column. This penalty is actually measures the lost opportunity. One forgoes or one misses if the smallest unit cost cell is not selected or chosen. This is the missed opportunity, by the way, the lost opportunity of a manager if he incorrectly or mistakenly selects the higher costs. In the second step is identify the row or column with the largest penalty, allocate as much as possible to the variable with the least unit cost in the selected row or column. Then the third step is adjust the supply and demand, and the last one is cross out the satisfied row or column. Let's move to an example. We will repeat the previous example with the Vogel's approximation method. So this example is unbalanced, so we have to add dummy demand to make it balanced. So we have to add dummy demand with a value of 5, and a transportation cost per unit cost becomes 0. So from now onward, we have to start Vogel's approximation method. Step 1, that is the difference between the smallest and the next smallest value. By the way, this green, yellow, and red column is used to put the difference between the smallest and the next smallest values. So from this row, as you see, from this row, the smallest one is 30, and we have to, the next smallest is 45, then we have to subtract 45 from 30, so we get 15 here. And from the second row, the smallest is 40, and the next smallest is 60, so, oh, sorry, very sorry. There is a smallest, another smallest, that is a dummy values here. So from the first row, the smallest is 0, and the next smallest is 30. So the value, the difference is 30 here. From the second row, the smallest is 0, as you see, and the next smallest is 40, and the difference is 40 here. And from S3 row, the smallest is 0, and the next smallest is 40, and the difference is 40. So we have to write here 40. And now let's see the column difference. From this column, the smallest is 40, and the next smallest is 50, so we have to write here 10. And from this column, the smallest is 70, and the next smallest is 75. We have to write here 5, the difference. From this column, 30 is the smallest, and 40 is the next smallest, so we have to write here 10, the difference. And here the smallest is 45, and the next smallest is 55, so the difference is 10. And from this column, the smallest is 0, and the next smallest is still 0, because there are 3 zeros. So the first is 0, and the next is 0. Their difference is 0. So we have to put 0 like this. So these are the differences. Then after, we have to choose the maximum penalty. From here, the maximum penalty is just 40, right? 40. So there are two 40s here. So we have to arbitrarily select, or we can randomly select one of the 40. So let's select the 140, that is this one, this 40, and from that corresponding row, we have to choose the smallest, because we already said that Vogel's approximation is a modified version of minimum sale cost method. So we have to select from the costs, we have to select the minimum cost, that is 0 from this row. So we have to allocate to that sale. And here we have 5, and here we have 17, so we have to allocate 5 too, and we have cancelled 5 here, and we have to subtract 5 from 17, and we remain with 12. And the next task is we have to cancel out the satisfied row or column, so we have to cancel the D5 column. D5 column is cancelled. Then the next task is to repeat the step again. So we have to write the difference between the list and the next list values. So from the row, the list value is 13, and the next list is 45. So here we have to write 15. And in the second row, 40 is the list, and the next is 60. So we have to write here 20. And S3, 40 is the list, and 50 is the next list, and their difference is 10. And let's come to the column. By the way, in the column, still all the differences are the same. So we have to write 10 here, 5 here, 10 here, and 10 here. So it looks like this. And we have to choose the maximum. We have to allocate the largest penalty, the the largest penalty from this yellow row and column is 20. So correspondingly, the smallest cost is from this row, the smallest cost is 40. So we have to allocate the corresponding, that is, we have 10 here and we have here 12. So we have to allocate 10, and 10 will be cancelled from here, and 10 is subtracted from 12, and the remaining here is 2. And when we cross out the satisfied row or column, we have to cross out, we have to cancel out the D3 column. So we remain these 3 columns. From these 3 columns, we have to again repeat the steps. So let's take the difference between the list and the next list. So from here 45 is the list and the next list is 50. So we have to write here 5, the difference, and from here 60 is the list and 65 is the next list. So we have to write 5, the difference, and the list is 40 and the next list is 55, and their difference is written on the red, that is 15. And let's come to the column. The column remains the same. By the way, the difference for the columns is 10 for the first column, and for D2 column is also 5, and for D3 column we already cancelled, right? So there is no difference here, and for D4 column still 10 continues, and for D5 there is no difference because we already cancelled out. So it looks like this. Then after, we have to select the maximum penalty. The maximum penalty is 15, as you see the values in the red row and column. So correspondingly, we have to select the smallest, that is, the smallest is 40, because Vogel's approximation method is a modified version of least cost sale method. So 40 is selected, so we have to allocate for 40. We have to allocate for 40, the corresponding numbers are 16 and 10, so we have to allocate 10 here, and we have to cancel 10 from here, and we subtract 10 from 16, and the remaining is 6. Then we have to cross out or cancel out the satisfied row or column. As you see, D1 row is already satisfied, so we have to shed it D1 column, and the next task is we have remain with 2 columns, D2 and D4 columns. So we have to just put their differences, because there are only 2 values. The smallest value is 1 and the next smallest is the other. So we have to put their differences on the blue. So we have to just 75 minus 45, we have to write here 80 minus 60, 20, 70 minus 55, 15. Then the column difference is the same, by the way. The column difference is the same. So it looks like this. And then we have to choose, we have to allocate the largest penalty from the row and column on the green, on the yellow, sorry, on the blue row and column. 30 is the largest, so the first row is selected, and the smallest from the first row is 45, and we have to allocate on 45. 10 will be allocated and cancelled from the demand side, and 10 is subtracted from 12, and the remaining is 2. So the next task is cancel out the satisfied column or demand, column or row. So D4 column is already satisfied because the demand becomes 0, so we have to cancel out this. And the next task is, as you see, the supply. By the way, we can repeat the steps again, but it is better to make it short. And as you see from the supply side, there is 2, 2, and 6 supplies from each S1, S2, and S3 respectively. And here the demand is 10, so we just map, we just allocate these supplies, these 2 to D1, and these 2 to D2. Sorry, these 2 will be assigned for D2, and these 2 will be assigned for D2, and this 6 will be assigned to D2. Then once again, when we cancel all this, and we have to cancel this 10 as well, because 2 plus 2 plus 6 becomes 10. So we just allocate the supply column to D2, because D2 demands 10, so the supply is 10, the leftover supply is 10, so we have to allocate the supply column to D2. Then now we already allocated all the supplies. Then we have to cross out all. So the next task is we can interpret that S1 to item goes to D2 and 10 item goes to D4. From S2 to item goes to D2, 10 item goes to D3, and 5 item goes to D5. By the way, here 5 item is not going to or cannot go to D5 because the transportation cost is 0. So this 5 item remains in S2, in the origin, or we just put because it is left over. We already satisfy the demand because the supply is greater than the demand. So in the supply side of S2, there are 5 items left over. And from S3, 10 item goes to D1 and 6 item goes to D2. And the cost can be calculated by multiplying the per unit cost by the number of items. So we can calculate like 70 times 2 plus 45 times 10 plus 80 times 2 plus 40 times 10 plus 0 times 5 plus 40 times 10 plus 70 times 6. So the result will be 1980. As you see, this transportation cost is still better than the least cost method. So the Vogel's approximation method is somewhat nearer or somewhat closer to the optimal solution. In turn, the least cost method is somewhat closer to the optimal solution than the northwest corner method. This is an example to you, and try to find out the initial feasible solution for this unbalanced transportation problem using northwest corner, least cost method, and VAM method. If you have any problem or any question, you can write on the comment box. This is all what I have. Thank you for listening. Have a good time. Bye.